Now, using your imagination, we have a ladder, and the ladder is leaned up against the wall. The length of the ladder is not going to be changing. That's going to remain constant. But there are two distances that will be changing as this ladder moves around, because I'm going to move it. One distance from the base of the ladder to the wall. As I pull the ladder away from the wall, the base of the ladder away from the wall, that distance is going to be getting longer. The other distance that's changing is the distance from the top of the ladder to the floor. That distance is getting shorter as the ladder moves. Now, what we're interested in with this situation is the rates of change of these changing distances. As the bottom of the ladder is pulled away from the wall, how quickly that is pulled, how quickly this distance across the floor from the base of the ladder to the base of the wall is changing. That rate of change, and it's going to affect the rate of change from the distance from the top of the ladder to the floor. I didn't say that particularly well. But to kind of simplify that, what we're looking at here is the faster I pull the bottom of the ladder away from the wall, the faster the top of the ladder is going to come down the wall, which is kind of common sense. Now, what we're really interested in is that are those two rates of change, while they are related to one another, are they the same? If I pull the base of the ladder away from the wall at a constant rate, does the rate of change, does the top of the ladder come down the wall at a constant rate? Okay, pay attention as I do this. Now, I'm not perfect, but just give me the benefit of the doubt that this actually is being pulled away from the wall at a constant rate. And watch the top of the ladder and how fast it's moving down the wall. Now, it's not perfect because it hits that little ledge, the baseboard there. But I think if you watch that again, you'll see that the top of that ladder is coming down the wall and it speeds up as it's moving down the wall. It starts out kind of slow and then speeds up. So the question is, if we know the rate of change of the distance along the floor, can we find the rate of change of the distance from the top of the ladder to the floor?